under which we consider the one sample t-test, and we started with a two sample t-test. So we went through the one sample t-test. We saw, and I told that for every question, you have to follow these 5 steps. My exam marking scheme is according to these 5 steps. First, you write the statement of hypothesis, H0 and H1. Then determine the decision rule. Then the computations, that's the step 3 is computation. Step 4 is the decision. Step 5 is the interpretation. So we looked at this yesterday and went through example 7.1. Example 7.2, 7.3. Then the two sample t-test, we looked at example 7.4. Then we came to 7.5. So the assertion is that the mean daily expenses of sales staff is greater than that of audit. Because of the word greater than, this test is a one sample test. It's a one-tailed test. Just like I told that when you see the word greater than, more than, or less than, it indicates a one-tailed test. So this one is a one-tailed test. And a summary of the data is given. So you don't need to enter this information to your calculator and calculate the mean and the variance. So the mean and the variance are given. So can we conclude that the daily travel expenses of the sales department is greater than that of audit department? Can we conclude that? We can't tell till we conduct a formal test. So what is H0? H0 says that there's no significant difference between the daily travel expenses of sales staff and that of audit. Then H1 says that the daily expenses of sales staff, the daily travel expenses of sales staff is greater than that of audit staff. And we are testing this at 10% level of significance, that's 0.1 level of significance. Alternatively, you can define mu1 and mu2 to denote the mean daily expenses of sales and audit staff respectively. So you can write H0 states that mu1 is equal to mu2, and H1 is that mu1 is greater than mu2. So we are testing at 10% level of significance. So we come to the decision rule. First, it's a one-tailed test. And the second thing you state is the degrees of freedom. The degrees of freedom N1 plus N2 minus 2. That's the degrees of freedom. So that is 6 plus 7 minus 2, which is equal to 11. So you read T 0.1, 11 degrees of freedom. So the critical T value is 1.363. So here, as usual, we reject H0 if the computed T value is greater than the critical T value. And we retain H0 when the computed T value is less than the critical T value. So that is the decision rule. So we come to the computation. So we compute the t value using this formula, which we're given to you during exams. But before that, we need to determine the pooled variance. So this is a summary of the data. N1 is equal to 6. The mean for group 1, that's the sales staff, their mean travel expenses per each person is 712.5 Ghana cedis, with a variance of 3747.5. Then the sample size for the audit staff is 7, with a mean of 651.429. These are all given in the question. If they are not given, then you have to compute it yourself. But when they are given, there's no need of computing it again for the sake of time in exams. So the variance for the audit staff is this. So we find the pooled variance. So what's the variance for the sales staff? You substitute, you get 3747.5 times N1 minus 1. N1 is 6, so N1 minus 1 will be 5. Then the variance for the audit staff is this. Then the sample size is 7. 7 minus 1 is 6.
6.
So all divided by N1 plus N2 minus 2. Give me the answer. Check whether my answer is correct. 5102.11.
Yes, please. Correct.
Okay.
Okay, it's correct.
Good. So we substitute these values into this one. In fact, in this case, the sales staff, the mean for the sales staff will come first, and that of the audit will come second. So 712.5 minus 651.429 divided by the pooled variance, 1 minus the sample size of the sales staff, then plus 1 over the sample size of the audit staff. So check whether the value for the t is also correct using 1.537 is the computed t value. Is it greater than or less than the critical t value? The critical t value is 1.363, and the computed t value is 1.
It's greater.
It's greater, and because it's greater, we reject H naught.
Yes.
Because it's greater, we reject H naught. The daily expense of the sales staff is greater than that of the audit. Is greater because that was the H1. So it may use the H1 to draw your conclusion. That's the assertion of graduate teachers that the salaries of the average salary of graduate teachers is less than that of nurses. So we wish to test this assertion at 0.01 level of significance. Okay. The sample size of graduate teachers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that of nurses, the sample size 1, 2, 3, 4, 5, 6, 7, 8.
So why is it so?
No, the sample size need not to be the same.
Oh, okay.
It depends on the population. So first, step 1 is for statement of hypothesis. H0 says that there is no significant difference between the monthly salary of graduate teachers and that of nurses. Then H1 says that the monthly salary of graduate teachers is lower than the nurses. We use mu1 and mu2, where mu1 is the mean salary for teachers and mu2 is the mean salary for nurses. So mu0 says that mu1, H0 says that mu1 is equal to mu2, and H1 says that mu1 is less than mu2. Is that a one-tailed test or two-tailed test?
One-tailed test.
Yes, so we come to the decision rule. It's first you state that it's a one-tailed test. Because it's a one-tailed test, you don't need to divide the alpha into two. Okay? Then you determine the degrees of freedom. So what's the degrees of freedom? It's n1 plus n2 minus 2. That's 8 plus 12 plus 8, which is
18.
20, minus 2, which is 18. So the degrees of freedom is 18. Then you go to your T distribution table to determine the critical T value, which is T 0.01, 18 degrees of freedom. You rate T 0.01 and 18 degrees of freedom. Is my answer correct? Please check for me. Critical T value from the T distribution table is 2.552. Okay?
Yes, sir.
Good. This negative should be positive. So you delete it. This negative should be positive. It's not negative 2.552, it's positive 2.552. So here, because the T value, we are expecting it to be negative. That's why I use the absolute value here. Do you understand what I mean?
No,
Yes,
sir.
sir.
Because x1 is expected
No,
to be
sir.
less than x1 is expected to be less than x2. So I'm expecting the T value to be negative, the calculated T value. So you use the absolute value. When you get the negative, remove the negative and draw your conclusion. Do you understand what I mean?
Yes.
So x1 minus x2. First, we determine our pooled. I'm on the computation now. So first, determine the pooled variance. So that will be S1 squared, N1 minus 1, S2 squared, N2 minus 1, all over N1 plus N2 minus 2. So when you substitute the values, it will be the variance here times N1 minus 1. N1 is 12. So N1 minus 1 will be 11. Then the variance of the nurses is this times N2 minus 1. N2 is 8. 8 minus 1 will be 7. So check whether this answer for the pooled variance is correct.
Yes, sir.
Great. So we compute X
Yes,
bar,
sir. That's
bar,
correct.
the mean for the teachers minus the mean of the nurses divided by square root of the pooled variance into bracket 1 over the sample size of the teachers plus 1 over the sample size of the nurses. Then I'll taught you how to compute this thing once so that you get your answer straight out. So input this into your calculator. I taught you yesterday how to do it. Then check whether my answer is correct.
Okay, sir.
Great.
Sir, please, what if they give the standard deviation instead of the variance?
If the standard deviation is given, this time we use the variance in the computation of pool variance. So you square it. When the standard deviation is given, square it to determine the variance and use the variance to work.
Okay.
Great.
Sir, please, I didn't get that. Kindly come again.
She was asking if instead of variance, the standard deviation is given. When there is no square, then it's a standard deviation. When the standard deviation is given, you just square it. If it's just S1, then find S1 squared to determine the variance. Because in this case, the variance that we use and not the standard deviation. But in this case, I'll give you the variance, so you don't need to worry.
Okay, sir.
You don't need to worry. But if the standard deviation is given, you need to square it. Okay, so that's correct.
Negative out.
So yeah, I take the negative out. So because 0.706 is less than 2.522, 2.552, we fail to reject H naught because the decision is that when it's less than, you retain, and when it's greater than, you reject. But because it's less than, we retain H naught. And when we conclude that there is not enough evidence to conclude that the monthly salary of graduate teachers is lower than that of nurses. You say that we fail to reject H naught, or we retain H naught is also correct. We fail to reject H naught is a correct statistical word, but business people sometimes they use the word retain, so that's why I'm also using that one. So in your decision, you say that we fail to reject H naught, but in your conclusion, you say that we don't have enough evidence. Your verdict, we don't have enough evidence to conclude that H1 is true. And H1 says that the monthly salary of graduate teachers is lower than that of nurses. We don't have enough evidence that that statement is true.
Please, this one, it was a standard deviation that was given. So we are going to square the standard
Exactly
deviation to
so.
get the variance.
Exactly so.
Okay. Okay.
Exactly so. So this one is a standard deviation which is given, but you need a variance when you are doing the computation. You need a variance. So you square this. What is 5.2 squared? From your calculator, what is 5.2 squared? It's with 25 point something or close to 30. Between 25 and 30.
27.04.
27.04.
Good. So you use 27.04 for
For the full variance.
band A. That's a standard, that's a variance. Then for this one, what do you use?
23.04.
23.04. So that's what you use in your computation when you are finding the pooled variance.
Okay.
So when you use a standard deviation, it will be wrong. Though the data is not
Okay.
provided, the summary is given. And all that you need is the summary, not the actual data. So that's question one. So Gordon, kindly notice so that you put it on our platform. So we move to, for the next 1 hour or less, we are going to look at the chi-square test.
Hello, sir. Please, a question on the assignment.
What do you mean?
You said we should determine if there is a statistically significant difference. So this means it's a two-tailed test, and alpha needs to be divided by
Yeah,
2.
exactly. So it's a two-tailed
Thank
test.
you.
It means you
Okay.
divide this alpha by 2. So you use 0.025 to solve instead of 0.05. This is chapter 8. We are looking at chi-square test of independence.
Mhm.
So the chi-square test of independence determines whether there is an association or correlation between two categorical variables. So here we are going to talk about two categorical variables. It is a non-parametric test. This test is known specially, it's known as the chi-square test of association. And the test utilizes what we call contingency table, or contingency table is also known as the cross tabulation table, or in SPSS it's called crosstab. And in some literature, it's also known as two-way table, contingency table. So what do we refer to as a contingency table? First, before we look at the contingency table, what are the assumptions? So we have 3 assumptions here. First of all, the 2 variables you are considering should be ordinal or nominal. That is, the 2 variables should be categorical. I think the first day I taught you what we mean by a categorical data. Okay. So here the 2 variables should be categorical. So each of the 2 variables should have 2 or more levels. I will show you what it means. And the data in the cells should be frequency or count of the cases. So first, what is a contingency table? This is an example of a contingency table. Please, can you see my table?
Yes, sir.
Yes,
Okay.
sir.
So here, NE Media Incorporation employs hourly workers and salary workers. The human resource manager surveyed 1,000 employees about their satisfaction level with the current healthcare benefit program. The employees were then classified according to their pay types, whether they are salary workers or hourly workers. So we are pay type as one variable, which have two levels, salary workers and hourly workers. Then we are satisfaction level, satisfaction, which are three levels, satisfied, neutral, and dissatisfied. And out of the 1,000 workers, 80 of them who are salary workers say that they were satisfied with the new health care benefit program. How do you interpret this 330? How
Hello,
do you
sir.
interpret this 330?
So the 330 workers who are 330 of the hourly workers says they are neutral.
Yeah, 330 out of the 1,000 workers who are hourly workers say that they are neutral. So these are just frequencies. They are no observation. They are frequency. So when you add all of them, you get the 1,000. So we classified the two variables into a table. And when you classify two variables into a table, we call this table a contingency table. So this is an example of a contingency table. Have I made myself clear? And what is a level? How many levels do we have for the pay type? We have two levels. Two levels.
Two levels.
And the satisfaction, how many levels? We have three levels. So we say we have two rows. We have two rows and three columns. The number of rows are two. These are just the totals. I can decide to omit them in the question. They are the total for columns and total for rows. And this is a grand total. Please, you understand? So there are only two rows. There are two levels for pay type and three levels for satisfaction. So what is a research question here? The research question is that, is pay type and satisfaction level correlated, or does one pay type determine his or her satisfaction level? Or can we say that there is an association between the pay type of workers and their satisfaction level? Or does a pay type of a worker determine his or her satisfaction level? So this is the research question. This is what we want to test. Is there a correlation between pay type and satisfaction? So that's the research question here. And how do you determine that? So the question at the 0.05 level of significance, is it reasonable to conclude that pay type and level of satisfaction with the health care benefit are related? So we want to determine whether pay type and level of satisfaction are related. Or we want to determine whether there's a significant correlation between pay type and level of satisfaction. Or we want to determine whether there's significant association between pay type and level of satisfaction. So that is what we are testing. And we are testing at 0.05 level of significance using this contingency table. Have I made myself clear so that we move to the solution?
Yes, sir.
Yeah, I'm listening to your question. Oh, no question. Okay, so we move on to the solution. So what are the 5 steps I gave to you? Number 1, step 1.
State the hypothesis.
Yeah, so step 1 is a statement of what? Hypothesis. I told you with the MBA student, I don't require you to write the choice of test for now. So step 1 is a statement of hypothesis. So H not says that, let me use this style. H not says that there is no significant association between satisfaction and pay type. There is no significant correlation between satisfaction and pay type, the level of satisfaction and pay type. There is no association. It means the correlation is 0. There's no correlation between satisfaction level and pay type. And H1 says that there's significant relationship or association or correlation between the level of satisfaction and pay type. So this is the null and the alternative hypothesis. And we are testing this at 0.05 level of significance. So that's step 1. What is step 2? What is step 2?
Decision rule.
Decision rule. Thank you. So step 2 is a decision rule. So here, there's nothing like 1 tail test and 2 tail test. So there's nothing like that for this test. It's the number of rows minus 1 times the number of columns minus 1. How many rows do you have? How many rows do you have? We have 2 rows.
2.
And how many columns?
3.
3.
So subtract the number of rows by 1 and subtract the number of columns by 1, then you multiply. And that's the degrees of freedom. So this will be 1, 2 minus 1 is 1, and 3 minus 1 is 2. So the degrees of freedom will be 1 times 2. Do you understand?
Yeah, please
Please,
come
can you
again.
come again?
So the degrees of freedom, you reduce the number of rows by 1, reduce the number of columns by 1, then you multiply. So it will be 1 times 2. For instance, when you look at this question, how many rows do you have?
3.
3.
And how many columns? How many columns do you have?
3.
And how many columns do you have?
4.
4.
So what will be the degrees of freedom? If it's 2 times 3, reduce the number of columns,
3.
rows by, reduce the number of columns by 1, which will be 2, and reduce the number of rows by 1,
Rows by 1, which
will be 2, and reduce the number of columns by 1, which will be 3. So the degrees of freedom will be 2 times 3 for this question. What will be the degrees of freedom for this question? How many rows do you have?
4.
How many columns?
3.
So the degrees of freedom will be 3 times 2.
Yeah.
So here the degrees of freedom will be 3 times 2. So that's the way we determine the degrees of freedom. So let's go and continue with the question. So here, what will be the degrees of freedom for this question? What are the degrees of freedom?
1 times 2,
Which is equal to
2.
2.
So that's how I got these 2. So the number of rows minus 1 times the number of columns minus 1. That will be 1 times 2, which is equal to 2. So you go into your book and open the chi-square table. There's a table for chi-square. So go into your book. I think table, is it A5 or so, or A4?
A5.
A5.
Page
Yes, please.
3.
Page what?
Page 338.
Correct. That's the chi-square distribution table. Can you see my table?
Yes,
Yes,
sir.
sir.
Okay, so this one is even easier to read compared to the T and the number distribution. So what are we reading?
Zero point zero five.
Yes, 0.05.
Yeah, 0.052 degrees of freedom. 0.052 degrees of freedom. So go to the table, locate 0.05 at the top here.
5.99.
So 2 degrees of freedom. This will be it. Please, can you see?
Yes, sir.
Yes.
0.05, 2 degrees of freedom. So it's 5.99. So that's how I obtained the 5.99 on our slide. So the critical T value is 5.99.
Yes,
So,
Yes, sir.
so that's how I obtained the 5.99. So reject H naught if the observed value or the computed value is greater or equal to 5.99, or retain H naught when it is less than 5.99. The same style. So you reject when it's greater than, retain when it's less than the critical value. So now we come to the computation. So that's where the work is. The computation. The computation. So first, can you see? So this type of testing is when you have 2 categorical data and want to determine whether there's a correlation between these 2. You have 2 variables which are categorical. And we want to find whether there is a correlation between those 2 variables. So this one we are finding correlation. So that's why in the hypothesis, we say that H naught says there is no significant correlation. Relationship means correlation. Another word for relationship or association. Either you use the word association, you use the word correlation, or use the word relationship. So there's no significant correlation between the level of satisfaction and pay type. So here there are 2 categorical variables, and you want to see whether they are correlated. Whether one pay type can determine satisfaction level. So that's the difference. But the two sample t-test is a comparative analysis.
Yes.
It's a comparative analysis. For instance, we want to compare the performance of males and that of females. The two sample t-test is a comparative
Then we
analysis.
use that time.
Are you saying it? So that one is different from this one, but this one is a correlation, while there's a relationship between the two categorical variables. Have I made myself clear?
Yes, Doc, you have.
Great.
You.
And I repeated it here, but I added something in parentheses. You see the 80, 40, 30, 370, 330, 150 were originally given in the question. Are you saying it?
Yes.
Good. So how did I obtain the one in the bracket? In fact, here the 80 is called the observed value. Then the one in the parentheses, is called the expected value. So we have the observed and the expected. But how do you determine the expected? The observed is always given in the exams as part of the question. But how do you determine the expected? So you take your calculator and I'll show you.
Okay.
Are you taking your calculators?
Yes, Doc.
Thank you. So what I've highlighted was the observed value.
80.
80.
And what is the row total for that observed value? What's the row total for that observed value?
150.
150.
450.
150.
What is the
450.
observed value? What is the row total for this observed value?
150.
150.
And what is the column total for this observed value?
450.
Okay, so do 150 times 450 divided by 1000. Row total times the column total divided by the grand total. What will be the answer?
67.5.
So that's how I obtained the 67.5 here.
Okay.
Wow.
So let's come to this cell.
Sir, please come again. Come again.
I'm continuing. So we have our
Say,
6
come
cells.
again.
I'm continuing. We have our 6 cells. So if you don't understand the first one, you understand the second one. So this second one, this 40, what's the row total?
150.
150.
What's the column total?
370.
So do 150 times 370 divided by 1000. Row total times the column total divided by the grand total. What is the answer?
55.5.
Great. So that's how I obtained the 55.5 in parentheses. We call it the expected frequency. We have the observed frequency, which is 40, and the expected frequency, which is 55.5. Let's come to this one. What is the row total?
150.
What's the column total?
180.
So do
So 27.
150 times 180 divided by 1000. What will be the answer?
1,000.
27.
27.
27. So that's how I obtained the 27 in the parentheses. Have I made myself clear? Can you see that row total? Can you see the screen? Row total times the column total divided by the grand total. It gives you the expected frequency. Row total times column
value.
total. Row total times column total divided by grand total gives you the expected frequency. So we have the observed, frequency, which is given in the question, and we have the expected frequency, which is the row total times the column total divided by the grand total. Have I made myself clear? So check whether the expected
Yes, sir.
frequency for this one is correct. Is it correct? That's 850
Yes,
times
sir.
Yes, sir.
450 divided by 1000. Is my answer correct?
Yes, sir.
Yes.
Right.
Yes.
So let's check
Yes,
this
sir.
one whether it's also correct. That's 850 times 370
Yes,
divided
sir.
by 1000.
Oh, 330. Oh.
Is the answer correct?
Yes, sir.
850 times 370 divided by 1000.
It's correct, sir.
Yes, sir.
So let's check the first one as well, whether it is correct. 850
850
times 180
times
divided
180.
by 1000.
153.
153.
That is great. So then we come to this table. In the exams, it's only this table will be marked. This one will not be marked. So if you can write this one straight away, fine. If you can't, you can create this table first before this one. Well, it's this one that we need, not this table. So I write all the observed value and their corresponding expected values. So 80 and 67.5. Can you say 40 and what? 55.5. 30 and 27. Then 370 and 382.5. 330 and 314.5. Then 150 and what? 153.0. So take your calculator. Do you have your calculator with you? Sorry. The formula is observed minus what? The expected squared divided by the expected. That's the formula. That's what we are doing. Okay? So do this calculation for me.
Okay. Please,
The
but
first
what
cell.
formula is this? What exactly are we looking for?
So you work this one
Hello,
for me
Doc.
and I'll explain.
Okay.
Are you with me? So let's do the computation. Please listen to me. The first cell. The first cell. What is the observed value?
80.
80.
So type 80 minus what was the expected value for the first cell?
67.5.
Then you close the bracket, then you square. Then you move your cursor to the denominator, then divided by the expected value, which is 67.5. Then strike equal to and give me the answer on your calculator. So you observe minus the expected square divided by the expected. Give me the answer, 3 decimal places.
Is it
2.314.
315. 2.314.
5. 5. Yes,
Yes.
approximately.
Do you say 2 point or 3 point?
3 point. 2.315.
2.315.
So this is correct.
2 point.
2.
So this is
Those are
correct.
2.
No, sir. 2 point.
This is 2.
2.315. So it's not
Yes, sir.
correct.
Yes, sir.
Yeah, it's correct.
Great. So that is how I obtain That is how I obtain this value. Do you understand? 2.315. Great. So let's do the second one.
All right.
Do the second one. 40, observe is 40 minus the expected, which is 55.5. Then close the bracket squared. Then divided by 55.5.
$4.329.
Good. So that is how I obtain the 4.329 here.
Yep.
Good. So let's check the third one, whether it's correct.
Zero point three three three.
0.333 is correct.
Yes.
Great. The next one. 370 minus 382.5 all squared divided by 382.5 to 3 decimal places.
408.
So my
408.
answer is correct.
Yes, sir.
Yes, sir.
Let's do the last but one and check whether my answer is correct for that one as well.
Yes, sir.
0.764.
0.059.
No, we're doing the
Which
last
one?
You're
but one.
ahead
He's
of
doing
us.
the
Last
last
but
one.
one.
But we are working the
Okay.
last but one, the one I've highlighted. So that one is 0.764, which is correct.
Yes, sir.
So let's check the last one. Then after that, we add everything. We add everything here. So the last one will give us 0.059. Then you add everything in the
Yes,
last
Yes, sir.
column. Yep. Add everything in the last column. And when you add, that will give a total of 8.208. That will be the total. So this total is a computed value. And because this computed value is bigger than the critical value, remember the critical value? The critical value is 5.99 because 8.208 is greater than 5.99. We reject H naught at the 0.05 level of significance. And rejecting H naught means that there is significant correlation between level of satisfaction. There is significant correlation between level of satisfaction and pay type.
Pay type.
Or there is significant relationship between level of satisfaction and pay type. It means once pay type, individual pay type, the type of pay that you receive can determine your level of satisfaction. In psychology, it is true. H naught. in the beginning. H0 says that
Yes.
there is no correlation between level of satisfaction and pay type. And H1 says that there's significant correlation between level of satisfaction and pay type. So if H0 is rejected, you use H1 for your conclusion. That is it.
Oh, okay.
So that's what I've done for the conclusion or the interpretation. So we say that at the 0.05 level of significance, we conclude that there's significant relationship between level of satisfaction and pay type. So this question also has been solved. First, you write the two hypotheses. H0 says that there's no significant relation between stock shares owned, and level of financial sophistication of investors. When you read the question, you understand. There are two variables: level of financial sophistication of investors and the value of share. Okay, so you want to determine whether there is a significant association between the level of financial sophistication and the value of the share. We want to determine that, whether there's significant association between the two. This was also a past question. So you write your H0 and you write your H1. Then you come to the decision rule. First, you find the degrees of freedom, which will be 2 times 3. I've already explained it to you. Y is 2 times 3. So the degrees of freedom is 6. So you read from the chi-square distribution table, 0.056 degrees of freedom. What's the value? 0.056 degrees of freedom.
12.59.
12.59. So reject H0 when the computed chi-squared is greater than the critical value, or retain H0 when the computed chi-squared is less than the critical value. So this is the decision rule. So we come to the computation. So I determine we have the observed values. I determine the expected values. Are you saying it?
Yeah.
So how did I get this 216? How did I obtain the 216? Who can tell me how we obtain the 216 here?
Six
None of the following.
600 times 6.
600.
Divided by the 1,000.
600 times 360 divided by the 1,000.
And what is the answer when you do it on your calculator?
216.
Good. So then the next step, in fact, this table is not awarded any marks. The table that we award marks is this. So you write the expected and the observed. You write the expected on the observed in the table like this. Then you find the observed minus the expected square divided by expected. You do it for all the pairs of values here. Then you find the total. The total is 144. So the total is 144.977. And because the total here, the computer value here is bigger than the critical value, we reject H0. And rejecting the H0 means that you use H1 for your conclusion. That's it.
Okay, we'll go
Have you seen it?
Yes,
So
sir.
Yes, sir.
There's significant relationship between the two. There's significant relationship between the two.
Very big.
Yeah, very big one. Good. So we pick one of these as question 2. I think example 8.5 will be your question 2 for the exercise. Here we have 3 rows and 3 columns.
Yeah.
We have 3 rows and 3 columns. You write your hypothesis.
7.8.
The variable are job classes, the job class, and what pension plan. Is there significant correlation between job class and pension plans? It's question 2 for your exercises you're supposed to submit on Saturday, coming Saturday. So I'm explaining it. I see here, how many rows do you have?
3.
And how many columns?
3. 3.
So what is our research question? Is there significant relationship between job class and pension plan? Or is there a significant association between job class and pension plan? Or does one job class determine its pension plan, its or a pension plan? That's a research question. So does it seem that there is a relationship between pension plan selected and the job classification of employees? Are you saying it? So that is what we are testing.
Yes.
So we are testing at 0.01 level of significance. So what do you think that your null hypothesis will be in this question? It's an exercise, but I want to see whether you can write. Just say it. Anybody at all can answer. What should be our null hypothesis?
Number 1 is
If there is a significant association between the job class and pension plan.
What is the null hypothesis?
Okay, so the null hypothesis is that there is no significant relationship between job class and pension plan.
Okay, so you call it job classification. Because that's how we mention it here. Though it's job class here. So there's no significant relationship between job classification and pension plan of employees. Then H1 says what? There is significant association or correlation or relationship between what? Job classification and pension plan of employees. Then you come to the decision rule. What will be the degrees of freedom?
3 minus 1 and 3 minus 1.
It'll be 4.
Yeah,
4.
so it will be 2 times 2, which is 4.
Yeah.
So you read chi-squared 0.01 because the alpha now is 0.01, not 0.05. You read chi-squared 0.01, 4 degrees of freedom. What's the answer?
13.77.
Good.
13.28.
13.28, is that what you said?
No, it's 13.277.
No, 13.28.
13.28.
So 13.28, because the chi-square table is only to 2 decimal places. So 13.2 is a critical chi-square value. Then you do your computation. First, find the expected. Here it will be 52 times 110 divided by 330. And here it will be 52 times 150 divided by 130. Then you find the total, you find the calculations, then you find the total. And if the total is bigger you reject. If the total is smaller, you retain H naught.
Hello, sir.
Yes, I'm listening.
Okay, please. Why is it that you say H naught is there is no significant relationship when the question says it seems there is a relationship between N? Does it seem there's a relationship between the pension plan selected and the job classification?
So, like I
I
told
don't
you
understand why.
H not always contain equality. So H not say that the correlation is zero. There's no significant correlation, always. H not says that there's no
Okay,
correlation. The correlation is zero. There's no relationship, so the
always in any
correlation is
other
zero.
question.
So always H not contains the equality. So correlation is zero. No correlation, no relationship, no association.
Yeah,
Correlation means relationship. It means association. It's the same thing.
Okay, sir.
So you
Thank
don't
you.
interchange it. The researcher's hypothesis is always the H1.
Okay, okay.
So if there's no question, then we are finished for the day. So you present your exercises for marking next Saturday.
Thank you, Doc.
Is
Okay, sir.
Okay, sir. Thank you.